Python's simplicity and versatility have made it a favorite among developers around the world, with over 10 million developers using it daily for everything from web development and machine learning to network scripting. Python is packed with powerful features. However, many of us might not be leveraging these features to their full potential. In this video, I'll introduce you to a bunch of fantastic Python features that you might not be using to their fullest potential. Transform your messy file paths into smooth, object-oriented operations with the power of Python's Pathlib module. Many developers continue using older modules like OS and os.path, often out of habit, or simply because they're not aware of Pathlib's advantages. Since os.path has been around for so long, it's become the go-to for file system operations, especially for those who've been using Python for years. But Pathlib provides a modern, object-oriented approach to handling file paths. Instead of treating paths as simple strings, Pathlib turns them into objects, making path manipulations much more intuitive and readable. With Pathlib, you can easily join paths, check for file existence, read, write, and more, all with a cleaner, more consistent syntax. Additionally, Pathlib simplifies your code by reducing common errors, like incorrect path concatenation, and it works seamlessly across operating systems. It enhances code readability, making your scripts not only easier to understand but also easier to maintain. Consider switching to Pathlib and experience a smoother, more modern approach to file management in Python. With Python's data classes, you can create simple classes for storing data without extra setup. Just add the @DataClass decorator, and Python will handle things like initializing attributes and creating a readable representation of your objects. For example, this person class has 3 attributes: name, age, and email. By using @DataClass, we automatically get an initializer and a nice print format for the person objects we create. Data classes help keep your code clean and make it easy to work with structured data. Let's talk about a handy operator in Python called the Warus Operator. Introduced in Python 3.8, the Warus Operator allows you to both assign a value to a variable and return that value in a single expression. It's especially useful when you want to simplify your code by reducing the need to write out separate assignment statements. Let's look at an example. Imagine you want to check if the length of a list is greater than 3. Traditionally, you might first calculate the length, assign it to a variable, and then use that variable in a comparison. But with the Warus Operator, you can do it all at once. Here's how. In the first code, the string is evaluated twice, once when reading the input, and again in the if condition to check its length. In the second attempt, the user underscore input is assigned directly within the while condition, saving both time and space by combining the assignment and the length check into one step. This is especially useful in scenarios where input validation or repeated calculations are common. And setters. Getters and setters are like security guards for your data. They control access to values in a class, making sure everything stays safe and valid. In Python, we can use the @property decorator to make this process even smoother, so we don't have to call methods directly. Think of it this way. Imagine you have a bank account, and you want to make sure your balance is never negative. Without a setter, anyone could accidentally change the balance to a negative number, causing all sorts of problems. But with a setter, we can make sure only valid values are allowed, which helps keep our code safe and running smoothly. In the first example, without using a getter or setter, we create a bank account class with a balance attribute. Here, since there's no validation or restriction, we can directly set the balance to any value, including negative numbers. This can lead to issues, as a bank account balance logically shouldn't be negative. In the second example, we improve the bank account class by introducing a private attribute underscore balance and using the @property decorator. The @property decorator allows us to define a getter to retrieve the balance and a setter to validate any new value before it's assigned. This way, if we try to set balance to a negative number, the setter raises an error, ensuring the balance remains valid. This approach keeps our data protected and makes sure the code behaves as expected. Offers an easy way to speed up programs by adding memorization to functions. Memorization stores the results of expensive function calls, so if the same input is used again, it simply returns the cached result, drastically improving performance. This is especially useful for functions like a recursive Fibonacci calculation, which involves repeated calls with the same values. For example, without caching, each call recalculates the Fibonacci sequence from scratch, which slows things down. But when we add a _cache maxsize equals none, it stores previous results, speeding things up by eliminating redundant calculations. Let's look at the code to see this in action. The @_cache maxsize equals none. Decorator enables caching for the Fibonacci function, storing computed results and preventing repetitive calculations. This simple addition greatly improves performance, making _cache a powerful tool for optimizing code.